the first thing to know about a new air conditioning system is this statement from the Department of Energy. And what they say, it's common for contractors to install oversized air conditioners. And that refers to the tonnage. So we've already established the tonnage for your system. But there are various ways to establish that. The square footage of your house, how many trees and windows are around. We can get very technical about calculating that. But sometimes it's very simple, where we simply go, how's your unit been performing when it was doing well? And if people say it's been great, then we're going to leave that alone, right? The problem with oversizing it, and it says contractors, it's common for contractors to install oversized air conditioners. We're in America where people like things big and strong, right? And if you need a 3-ton unit and you say, well, let's install a 4-ton unit, what's going to happen is it's going to cool the house down and then turn off and not take as much moisture out of the house as it can do. And there's two things that it's doing for you. It's controlling your temperature, but it's also removing moisture from the house.
Okay.
And if you oversize the unit, you get into what is called short cycling. And it says short cycling prevents conditioners from operating at peak efficiency. So now that we know the size of your unit, that's what we're going to work with, right?
Okay.
So in your case, we did establish earlier that you need a 3-ton unit. So we're not going to spend any further time looking at that. What we're going to look at next are the different efficiency levels, the SEER ratings that I talked about earlier. There's a 14 and a 16 SEER, there's a 17, and then there's even a 20 SEER. And I'm going to tell you a little bit more about what's involved there.
Okay.
So let's just look at a few air conditioning basics. Outside you have your condenser, and inside you have this big air handler that consists of basically 2 parts. At the top here is what is called the coil, or the part that gets cold. Some people call it the chiller. And below that there's a bucket. And connected between these two things are these 2 copper lines that I'm sure you've seen outside. What happens is this condenser pushes gas, it puts it under pressure and pushes it to this coil. And when it gets to the coil, it gets released. And when you take gas from a high pressure to a low pressure, it cools down. And that's the magic of air conditioning. So this thing gets really, really cold. Below that, we have a motor that blows air over this cold thing. And then there's typically what is called a plenum on top of that, with pipes going out into your house. Okay? And one other thing happens is there's also a plenum over here with an area where air gets returned and gets back into the system. And finally, we have a furnace, which is in most cases a little gas furnace where the air blows over and gets heated up during the winter, or it gets cooled down during the summer.
Okay.
And this air gets blown through the house like this and then returns through the system, and that's how it circulates the air through the house and cools it down. There's another thing that happens. Droplets start forming on this coil, and that water drops down into this bucket and gets taken out of the house. So really what you have here is a built-in dehumidifier. And you know how sometimes in Georgia they say it's 95 degrees outside, but it feels like 110. That's because of humidity, right? Or if you live in Arizona, it may be 125 degrees outside, and they say it feels like 110 because the air is drier.
Okay.
Do you sometimes find that you put your temperature down at night?
Yes.
Okay. Why does it make you feel more comfortable, or what?
Yeah, I just get hot at night.
Yeah. So what that often actually refers to is the humidity, more so than the temperature. Because when the sun goes down, we know that there's more moisture around. In the morning we go out and there's dew on the ground, right? So the same thing happens with your house at night. There's more humidity around. And in order to try and reduce that, you punch the temperature down and it feels better. If you have a system that actually controls your humidity more effectively, you may find that you don't need to do that at night, that the same temperature would be comfortable to you at night. Okay. Any questions so far? Okay, good. So Laura, this part is really important. It says here, nearly 50% of all heating and cooling equipment in US homes never performs to its advertised capacity and efficiency due to incorrect installation. Nearly 50%.
Wow.
And then the most important day in the life of the system is the day it's installed,
Okay.
right? So I'm going to get a little technical with you here and show you more details of what a good installation entails. What are the important things? Well, I want you to understand that this is really the reason you need to choose this company. It's the reason I chose this company, because I did my homework and found out that these guys are just phenomenal in terms of how well they treat their people, the equipment they supply them with, how they organize themselves. It's that push and support behind the guys that are out there in the field to install your system that ultimately leads to a system that's going to last for a very long time and perform the way it's supposed to.
Okay.
Yeah,
Yeah.
good. I see a lot of it in terms of the lifespan of units. Sometimes I visit customers whose unit is basically died after 10 years, and in others after 20 years. And it's the same unit. They were the same when they came out of the factory. So what happened? It's not always a maintenance issue. I've seen units where customers change the filters regularly. The unit on the outside is clean, and yet the one lasted twice as long as the other. It comes down to installation, the quality of installation. There are quite a few small but very important things that have to be done correctly. And I'm going to show you a typical installation. I'm going to show you some pictures and talk you through those.
Okay.
Any questions so far? Not. Okay, good. So this is what our facility looks like in the morning. All the trucks are there loading up the equipment. Everything is pre-pulled for them, so they have a Y fitting like this would be on the truck. The worst thing about an installation is you get out to the job site and you realize you forgot something, right? So we take really great care to make sure that they have what they need.
Okay.
Everything is forklifted onto the back of the vehicles, so there's no risk of anybody dropping anything and damaging the equipment. This is another reason why we sometimes get asked, shouldn't I just buy my unit online and pay somebody to install it? You'll find that any reputable contractor really wants to take care of that unit from the time it gets picked up at the supply house up to the point where they get it at your house. So we do. You can see here, we take really good care of moving it. This is the crew that I followed. And you can see they have a lift gate at the back. And if you look carefully at this picture, there's actually a box of water there. So this is the before. There was the air handler and the furnace. And there's no pan underneath it. If that thing should leak water, it will be all over the floor, which in this case may not matter because it was in the garage. But this is the after, and as you can see there, we have a pan in it. There's a safety switch, and in fact, in this case, the ductwork was upgraded. This ductwork was not up to code. It's got single wall pipes, and it's got this tape, and there's a gas furnace burning just over here. So you can imagine this tape, when I touched it, it was brittle, right? It deteriorates over time. So eventually you're going to have carbon monoxide escaping out of here, and that could potentially get into the house. So we pull permits on all our work. And as you can see here, we upgraded that work. Okay. So we now have double wall pipe. There's no tape on it. This is designed to plug into itself. So it's a very, very efficient system. Again, that's the before picture and the after. As you can see, the house itself had the correct double wall pipe, but everything below it had to be upgraded.
So that was the installation that did that. They didn't do
The
it
previous
properly.
installation,
Okay,
yeah.
I see.
It may not have been a code issue at that time,
Oh,
yeah, but this has definitely been, it's a code issue today.
okay.
So when we do a new installation, we're going to take care of all these items. We're gonna bring it up to code.
Okay.
Yeah.
Do you think that happened because of fires or something like that?
Fires
Okay.
or people being harmed by carbon monoxide.
Oh, okay.
Yeah,
Yeah.
yeah. There's very strict codes about that
Oh,
now.
okay.
Yeah. So the other thing I commonly get asked by people is, why is my system leaking? And it typically starts leaking here or here, either in the condenser on the outside or the coil on the inside. And as you can see in this picture, it's pretty obvious why this thing started rusting, right? It's exposed to the elements, it's sitting right on the ground, and it's just not the way it should be placed. This is what it looked like afterwards.
Wow.
So we raised it with this pad, and the design of the unit itself allows for it to be raised. So that's one of those small things that will add more life to the unit. We removed the old unit. There we're bringing the new ones out. We have plenty of muscle there to move things. And here we're leveling the pad. It's best for the pad to be leveled because the blade that spins around does better if it's in a level position. Our guy here has his pickaxe, and he'll do a little bit of gardening in a day's work. He'll do plumbing, electrical, and HVAC. This was pretty egregious. You can see this electrical wire just running out straight into the unit. That's not up to code at all. Imagine a kid running past this thing and his foot gets hooked on this, right? Could rip that wire right out of that unit. So we corrected that by putting it into conduit like this, putting a shutdown box in, and then moving a new conduit to the unit itself.
Okay.
And what you can see here, the steel that this is connected to is nice and thick, right? And this is connected. It just looks strong. Sometimes if you look into some of the builder grade units, as they call them, the technicians will tell you that their screws actually strip out on those units. And what happens is you have, all companies have their normal brand, and then they have a builder's grade. And if they're producing and selling 100,000 of those a year, the only way they can really save money is by making the metal thinner, right? The rest of the production process is the same. And that's where we just don't really recommend going for those kind of brands. We secure the ground wire. Here we're disconnecting the gas, and again that's part of our crew doing it, so we don't have to call in a plumber. And here he's pulling out the old unit, so you can see this is the air handler and furnace, and this is the coil section. There's the coil from this picture sticking out at the top. And that's what it looks like. It became rusted. And these pipes are running all the way back there, back and forth like that. So if you get a tiny rust hole somewhere in there, it's just not possible to fix it.
Okay.
That's why eventually you have to replace the unit.
Okay.
Now, we do put a filter in here that you'll see here in another picture that takes moisture out of this line and will prolong the life of this unit. Here we're putting on the filter box, and he's screwing it in with these metal screws and also taping it down with metal tape. There's the new pan going in, the new unit. Standing up, it's raised on these legs so it can't rust if there's some water getting into the pan. This is really critical. So this is the point where we connect these old pipes to the new unit, right? And you can see how he cleaned these pipes up. He uses a special sandpaper that he rubs around those pipes to get them nice and clean like that. Now, imagine if he was in a big hurry and he cut this pipe to connect the two and then just slipped it over a section that looks like this old section, uncleaned, right? He could solder it in or braze it in, but that's the type of thing that's going to start leaking after maybe 5 years because of all this old carbon sitting there, right? So that's one of those little things that we take care to do right. The other thing we do is we braze this line, which means it's not soldered. Soldered is a method of using lead that melts at a low temperature. Brazing is done at a very high temperature, and this is actually a silver bar. So to get that to happen, we have to make this unit super hot. And here's a little video component where you can see how that happens. I've actually found a video online where a repairman had to go in and repair work that somebody else did, where they used lead for soldering. And you can see the guy working from morning until nighttime to fix this unit. And he's talking about the fact that he can't guarantee that this is going to work. He's trying his best. So this customer is paying somebody for another 10 hours of work to try and fix this unit, of which there's not going to be any warranty in the future because it wasn't done right the first time. So it's pretty risky if you don't work with a company you can trust. The same happens on the inside. And then we put this filter in that you can see there, the one I mentioned over here, right? And so now we have a closed system. So what we have now is all of these parts connected. And we need to make sure that it's going to hold pressure And how do we do that? Is we use a gas and we put the system under pressure up to 250 pounds per inch. So now it's up under pressure, and then we wait for 30 minutes. And when we come back after 30 minutes, it's still going to have that pressure. That's how we know that there's no leak in the system. Now, we talked earlier about how when we pressure this gas up, it comes up here and then it gets released. It actually goes through a tiny, tiny hole where it gets released. Now imagine when we did this brazing, some dirt got into this line and eventually works its way up into this hole. That means the dimension of this hole is now changed, and this unit's not going to operate at the advertised efficiency. That's what I was referring to in the book earlier. 50% of all units do not operate as advertised. So how do we prevent that from happening? Well, we come back and we vacuum the line. We attach a vacuum, you can see here, and we go down to minus 30 for 30 minutes. So now we have a perfectly clean line. It's perfectly cleaned out, and it's under a vacuum. And then the compressor section in this condenser is connected to these pipes, and it actually has the new gas already in the system. And there's a little tap that we open, and that puts it into the system. So now you have a system with nothing else but the new gas in there. That's perfectly clean.
Okay.
We then also check these pressures. If your pipe should be longer than normal, we may need to add some more gas. And there's all kinds of checks that are performed at the end, little tweaks to make sure the system operates at efficiency.
Okay.
Okay, any questions? Not good. Well, thanks for listening. Part of this includes installing a new thermostat for you that you can control electronically. And we finish up, we clean up after ourselves. We also have additional safety switches. One that sits over here that actually detects water flow. If this line should get blocked, it'll turn off the system. And then we also have this pan sitting underneath here with another safety switch that will detect water. So if for any reason this switch should fail and you should get water dropping in here, this switch will detect it and turn the system off. Okay, good. So just one other thing I want to show you, a couple of other before and after pictures. There you can see two systems and our new one, and beautifully raised off the ground. It's definitely going to prolong the life. That's the unit, the old unit, and this is the after. And we connected to the existing plenums, and there's the safety switch I talked about earlier, and the one that detects the water flow. And finally, here's your filter that takes moisture out of the line. Here's another unit where there was no water pan underneath it, and you had a wooden floor actually right around the corner from there. So if anything should go wrong there, that would create a lot of damage. And as you can see here, there we have the pan and all the new switches, as well as the upgrade of all the ductwork. There you go.
Okay.
All right. Okay, Laura, so finally we get down to the different SEER ratings, which is Seasonal Energy Efficiency Rating. So these to the 14 and the 16 SEER operate at one stage, and I'll show you what that means. The 17 SEER gas furnace will operate at a two-stage. In the case of a heat pump, which generates heats differently, the 16 SEER would also operate at a two-stage. But in your case, we're looking at gas, so we'll just talk about those. And then this one is called a variable speed unit, the 20 SEER. So let's say you leave your house and you set your temperature fairly high. It goes up to 80 degrees. And then you start heading back home and you say, okay, let's get it down to 70. You set your system for 70. What's going to happen with this one-stage unit is it's going to run at full. It's going to give it all the power it can and get down and then get up and down like this. And it's going to get it down to about 69. So a little lower than 70, because if it tries to just hit 70, it's going to go on and off, on and off. That's not good for the unit. It needs to cycle about 3 times an hour. So it's going to take it a little bit below the temperature. Then it's going to wait for it to get up to 71. Then it's going to turn on again and get it down to 69 and so on. So basically it comes on Now it reaches 69, now it turns off. Now the unit remains off while your house is getting warmer, and it turns on again. And now it runs and runs and runs until your house is cold and it turns off. And so this is like a light switch. It's either on or off. There's no in between. And as long as the unit is sized correctly, and that happens about 3 times an hour, it's okay. But there is a way to be more efficient. With this 2-stage system, let's say it's 80 when you turn it on, and it starts bringing it down. Now it gets close to the 70 that you've set, right? It's going to run at 100% efficient capacity when it's bringing it down, because it has a lot of work to do, right? When it gets close to that temperature, it's going to go to 50%, right? That's the second stage. So now it's going to start doing this. And it's going to keep much closer to that required temperature. It's not going to use as much energy to do it because it's running at half capacity. Let's say it gets really hot outside this time of the day, there's a lot of sunlight, and it's battling to get down to temperature. Then it's going to kick back in at 100%, okay, in order to achieve that target. There's one other thing that's going to happen. This process of taking moisture out of the house is going to be prolonged. Unlike this situation where it completely stops and this isn't continuing, in this case it's going to continue. So you can see what I talked about earlier, where it feels better if there's less moisture in the house. That's what this 2-stage unit is going to achieve. And finally, the 20 SEER unit is going to look roughly like that. It's designed to be less than half a degree of the setting. You can even set that unit to just the humidity that you want in the house, other than the temperature. And it's a smart system. It will look at the outside humidity, temperatures, that type of thing, and maintain that. And there's obviously a premium to pay for those. So given this, which unit do you think you would be more inclined to purchase?
Probably that one.
Yeah, good.
Yeah.
That's a good choice.
So what is the efficiency difference? How much am I going to save, do you think, on these different units? Why would it be worth spending more on this? How long would it take me to recoup my money?
Yes, that's a great question. So we have a SEER scale over here. When you purchased your old unit, it was a 10 SEER. And every 5 years, you're losing 1 point of efficiency.
Okay.
Right? So yours is 18 years old, so you're probably operating at a 6 SEER right now. So this becomes the baseline that we have to look at. Then we look here at the 14 SEER, and you can see that you'd save 57%. So even if you bought the lowest SEER rating that we have right now, you're still going to see a 57% saving.
Really, per month?
Yes.
Wow.
Now keep in mind, about 2/3 of your bill is towards air conditioning.
Oh, yeah.
Particularly during the summertime.
Okay.
Right?
Yeah.
So if you're spending, what are you spending roughly per month? 400. Okay. Let's be generous and say it's 300. We work with round numbers. 200 of that is going towards your air conditioning. Because in the winter, you're not going to spend that much. You're using gas to warm the house.
Okay.
Right? So $200 is going to go towards your air conditioning bill per month. You can save 57% of that.
Oh,
That's over $100.
That's significant.
It's a very significant saving. If you're saving $110 per month over a 12-month period, over 10 years, which is the period that we warrant the unit for, it's 110 times 12 times 10. That's $13,200 in savings over a 10-year period.
Wow.
And
that's just the lowest one. That's just replacing the system I have.
Right.
What is it on the other?
On the others, on the 16 SEER, it's 62%. And on the 20 SEER, which is not on this list, it gets very close to 70%.
Okay.
Yeah. So definitely worth making that investment.
Yeah.
Yeah.
Okay.
Okay, any other questions? Okay, good. So, Laura, we can have a new system in your house tomorrow.
Wow, really?
Yeah. So, are you ready to go ahead and sign up and we can get this done?
Yes,
Good.
I am.
Well, we'll have you comfortable at the end of the day tomorrow.
Okay,
Thank you.
thank you.